Assalamualaikum and good day all. Today we are already in tutorial 3. We will discuss about electrical charge and Faraday law. So the first we will look into part 1 of tutorial 3. We will discuss about electrical charge and then we will go to tutorial part 2. We will discuss about the Faraday law. Yeah. Okay, we go first uh, on the tutorial part 1. Uh, okay, we will go directly to the first question. What is the magnitude of the force, positive 25 microcoulomb charge exert on the positive 2.5 microcoulomb and then charge 20 X centimeter away. So as we know, the formula of the electrical charge is F. The force is equal to for F equal to K times to Q1 and our electrical charge first to electrical charge second, Q1 times to Q2. Okay, we just try to derive the equation. Uh, so F equal to okay, constant charge, electrical charge, to electrical charge first and second. So derived by square distance. So we just starting the question with the known parameter first. So we know the known parameters. The first one is Q1. Q1 here equal to plus 25 in the unit microcoulomb. And then Q2 positive 2.5 microcoulomb. Microcoulomb. So as we know, the standard of electrical charge is K equal to 8.9 988 times to 10 power 9 Newton or meter square per square kilometer. So now we can uh, finish it, the calculation, just input inside the equation. Okay, please convert into the unit SI in 28 times 2 power negative 2 meter. Okay, now we can finish it, the calculation. So I hope we can get the final result is equal to 7,200 Newton. Okay, for next question, you can use this formula also. Yeah, still using this one. But now we have uh, combination of Q charge. Yeah? We have the Q1, Q2, and Q3. But the question is, you should be calculate from the Q1. If we consider the Q1 positive 75, the Q2 is positive 48, and then you combine other F is 75 to negative to 85. Okay, and then combination, combination. So the R is 0.35. So the question, calculate the net force on each charge due to the other two. So you should be combine. If we calculate F, so I just erase first. This one, you should be calculate F positive 75. Okay, you should be combine 70 or 5, Q1. So better I use formula first. Q1 is 75. Q1 here, and Q2 is 40. This one is 75, and then this 48 in the negative K direction over to the R square, and then positive to Q1 and Q2 same with the number, and then it should be R2. This one R1, this one R2. So remember, we have 3 points here. So every distance consider 0.35. And then here also 0.35. So if we jump 2 step, 2 point from here for starting, we should be second R is times 2. Okay, so now here is 0.35. Now change to 0.7. Okay. Now other F is for question number 2. In the 48. So from 8, Q1 is 75, Q2 48, and then second condition I is second I, similar. Q1 is 48, and the second is 80. So now we change to 48, and then the second one is 48 turn to 75, and then this one first distance, 1 square plus 2. Second one is 85. 2. Okay. Okay, similar. Don't forget to times with the K. This also have K. This one also have K. So just we can put outside this K. And then after that you calculate for F negative 85. Yeah. Okay, just repeat. So Q1 is the 85. And then the second one 75. Plus 2. Okay, this one time to K. Yeah? Okay, now you get the resultant, just sum of the F. So this one F75, this one F48, this one is F negative 85. Okay, your answer number 1, number 2, number 3 same, similar condition. And then also number 4, different, just significant difference is maybe number 5. Okay. Yes. Number 5, you have the source in the Q1 in the certain distance, and the Q2 also in the certain distance by reflect to point A and B in certain angle. So now you can calculate between the Q to the point A and B. For number 5, you can calculate first by drawing within the Q. And then you can calculate the theta here, how much the angle. Reflect the distance. This one is actually distance. So the distance we will use for implement the formula of E electrical field. So the formula electrical field is different. This one is the formula for electrical force. This one is electrical field. So the formula is K times 2Q over to distance D square. So because it's reflect by certain angle, you can finish it by sinus theta. So the electric field you can find by this formula. Okay, this one is part of 1 in the tutorial 3. Now we go to part 2 in the tutorial 3. In part 2, we will implement the Faraday law. Okay, please check question. Question number 1. the potential difference between two short section of parallel wire in A is 24 volt. They carry equal and opposite charge magnitude is 25 PC. This one is unit. What is the capacitance of two wires? Okay, I try to answer by implement formula of Q equal to C times to V. C is capacitance and V is the voltage, or potential. So the Q is the column. It means the capacitor of electrical is determined by Q equal to QC. Okay. Now we check the question. The question asking about the capacitance. So capacitance is referred to C. So C equal to, can modify the formula, is by Q over to V. Okay. Just simple. We just input inside of the formula. Now we can answer the C. Okay. Very easy. Maybe quite difficult if we refer to number 2, because it's not only about the series. We should be calculate in the parallel condition. Okay, now we have 0.5 microfarad and also 0.8 capacitor are connected in series. So battery is 9 volt. Calculate A, potential difference across each capacitor, and B, the charge on each. And then repeat part C, repeat part A and B, assuming the two capacitors are in parallel. So we have a condition in parallel in part C. Okay, we try to answer. So we have here two capacitor, 0.5 and 0.8. So we try to derive the formula first. Q1 equal to Q2 equal to Q equivalent. Okay, now we can calculate the equivalent is C times to V. So because it's a capacitor in the parallel, so we can rewrite in the parallel formula by times to V. So now we can finish it. The 0.5 in the unit of picofarad times to maybe I write here 0.8 times to 0 picofarad to farad negative 6. Now time to 9 volt. So you can finish by your calculator by yourself, find it. So now we back to the question number A. The question is how to calculate the voltage 1. Yeah, what happened in the condition wiring in the wire Y. So we can calculate. So what you find here using to this one. Then for V2, every wire is similar because Q1 equal to Q2, so you can use same Q here and then divide by C2. So now you can get every wire have the different voltage. Now you are already answer the question number A. Now back to question number B. B is calculate the Q. Okay, here. This one is for B, question number B. Equal to Q equivalent. So this one is we can get from question number A. Okay, now for number C in the parallel system, circuit in parallel. So we have V1, we have V2, so we have Q1. Okay, Q1 we can recalculate by C1, V1. And then Q2 we can recalculate by Q2, C2, M2, V2. Okay, now we can finish it. The question number 2. Okay, now for number 3, you should be follow the figure to answer the question. Okay, we have in series this one in series. So this series is parallel to the C3. So careful to answer question number 3. For number 6, also almost similar to number 3, but the circuit will consider series only in the part of this one, the left side. But when we come to this one, is considered the parallel. Yeah. So only different two tab here. So the first one is other. This one is considered other, and this one is considered other type. Okay, if you have confusing to answer tutorial 3, please discuss with me anytime. You can message me or you can call me for tutorial 3. Okay, that's all for tutorial. Please answer the tutorial, all the question for your attendance and submit to week 14. Yeah. Thank you. Assalamualaikum and good day all.